The particle model of matter can be used to help describe the densities of substances and the different states of matter. It says that everything is made up of lots of tiny particles. Density is a measure of the compactness of a substance. It relates the mass of a substance to how much space it takes up, i.e., it's a substance's mass per unit volume. The symbol for density is the Greek letter rho. It looks like a P, but it isn't. There's a formula for finding the density of a substance. Density can also be measured in grams per centimeter cubed. An example is this copper cube. Copper cube has lengths, side lengths of 5 centimeters. That means the volume will be 5 times 5 times 5, which is 125. And we know that the mass is 1,120 grams. So we can use this equation to calculate density. Density equals mass divided by volume. 1,120 grams divided by 125 centimeters cubed equals 8.96 grams per centimeter cubed. The density of an object depends on what it's made of. It can be explained using the particle model of matter. A dense material has its particles packed tightly close together. The particles in a less dense material are more spread out. If you compressed the material, its particles would move closer together, and it would become more dense. You wouldn't be changing its mass, but you would be decreasing its volume. 3 states of matter are solid, like ice, liquid, like water, and gas, like water vapor. The particles of a substance in each state are the same, only the arrangement and energy of the particles is different. In a solid, strong forces of attraction hold the particles close together, in a fixed, regular arrangement. The particles don't have much energy, so they can only vibrate about their fixed positions. Liquids have weaker forces of attractions between the particles. The particles are close together, but can move past each other and form irregular arrangements. They have more energy than the particles in a solid. They move in random directions at low speeds. There are almost no forces of attraction between the particles in a gas. The particles have more energy than those in liquids and solids. They are free to move and travel in random directions at high speeds. The particle model helps to explain the properties of the different states of matter. The density of a substance is generally highest when it is in solid form, as the particles are closest together. Liquids tend to be less dense than solids, and gases are the least dense. Their particles are spaced far apart. Gases and liquids can flow because their particles can move past each other. The particles in a solid can't move anywhere. They can only vibrate in their fixed positions, so solids can't flow. Gases are compressible. The particles in a gas are very spread out, which means you can squash a gas into a smaller volume. You're just reducing the distance between the particles. The particles in liquids and solids can't really get much closer together, which is why only gases are easily compressible. You need to be able to measure the density of a substance for one of the required practicals. The method you should use depends on the type of substance. First, use a balance to measure the object's mass. You then need to find its volume. If it's a regular solid like a cuboid, you might be able to measure its dimensions with a ruler and calculate its volume. For an irregular solid, you can find its volume by submerging it in a eureka can of water. A eureka can, or displacement can, is essentially a beaker with a spout. To use one, fill it with water so the water level is above the spout. Let the water drain from the spout, leaving the water level just below the start of the spout. This way, when you put your solid object in, all the water displaced will pass through the spout, giving you the correct volume. Place an empty measuring cylinder below the end of the spout. When you put your solid object in the eureka can, it causes the water level to rise and water to flow out of the spout. Once the spout has stopped dripping, you can measure the volume of the water in a measuring cylinder. This is the volume of your solid object. Now you can substitute the object's mass and volume into the density formula and find its density. If you're measuring the density of a liquid, place a measuring cylinder on a balance and zero the balance. Pour 10 ml of the liquid into the measuring cylinder and record its mass. Pour another 10 ml into the measuring cylinder and record the total volume and mass. Repeat this process until the cylinder is full. For each set of measurements, use the formula to find the density. Finally, take an average of your calculated densities, and this will give you a more precise value for the density of the liquid. From this video, you should be able to recall and apply the density formula. You should know that the particle model can be used to explain the states of matter and the differences in density. You should be able to draw simple diagrams to model the differences between solids, liquids and gases, and explain the differences in densities between the different states of matter in terms of the arrangement of the atoms or molecules, the particle arrangement. Go back to Google Classroom, make sure that you answer the question that goes with this video, and I will see you in the next video.